Hello, warriors. This is Mrs. Kuklo, and today we're going to take a break from slope and we are going to work on proportional and non-proportional relationships. Though you will see there is a little bit of slope in this skill. Our goal today is to figure out how we can tell if a relationship is proportional, if we are given a table, if we are given a graph, or if we are given an algebraic rule. So we are going to find 3 different ways that we can determine if a relationship is proportional or not. The first way that we are going to look at is using the table. So think back to our pizza delivery question and our pizza without a delivery that we worked on last week. Our question says, consider the tables representing the cost of pizzas with delivery and the cost of pizzas without a delivery charge. So this is what we worked on last week. We knew 0 pizzas was $0 without a delivery. 1 pizza was $7. 2 pizzas was $14. 3 pizzas was $21, and 4 pizzas was $28. But today we're looking at the ratios. So we want to look at the ratios. And I'm going to zoom in so I have space to write. As we learned previously, money is usually what's in the numerator. So our ratio is going to be the ratio of the cost to the pizzas. We don't really worry about the first one, the 0-0 relationship. We know that 0-0 relationships can be proportional. So we want to start with our first pizzas. So I have $7 for 1 pizza. So my ratio is 7/1. And 7/1 will simplify to 7. Now I look at my second ratio of 2 pizzas for $14. So I have $14 for 2 pizzas. And that will also simplify to 7 because 14 divided by 2 is 7. Then our next number is 3 pizzas for $21. So my ratio is 21/3. So your ratio is 21/3, which also simplifies to 7 because 21 divided by 3 is 7. And last, I have 4 and 28. So it's cost over pizzas. So I do 28/4, and 28/4 will also simplify to 7. Next, I want to look at the table for my pizzas with a delivery charge. So remember with the delivery fee was $5. So that one is with the $5 delivery fee. Zero pizzas cost $5, but that was the one that doesn't make sense. We just kind of skip that one for our ratio and we look at the next one. We are still doing cost over pizzas. So it's still the money, the 12 over the pizzas, the 1. And 12/1 simplifies to 12. Now, 2 pizzas cost $19. So I do $19 for 2 pizzas. That does not simplify. 19 over 2 is in the simplest form. Next, I have 3 pizzas for $26. So that's 26 over 3. It also does not simplify. 26 over 3 is in simplest form. And last, I have 4 pizzas for $33. So that's 33 over 4. And 33 over 4 also does not simplify. So it was in simplest form. Next, I want to take a look at these graphs. I want to analyze and see what things do I notice are the same about them. What do I notice about the graphs? What do I notice is different? Our first question says, what do you notice about the ratios of the pizzas without the delivery? So if I look at my pizzas without the delivery, that would be the first table. I notice that they all simplify to 7. And part B says, what do you notice about the ratios of the pizzas with the delivery fee? Well, I notice that they do not simplify. So my ratios of the pizzas with the delivery, they happen to be equivalent ratios because they all simplify to the same thing. So they're equivalent ratios. They will all simplify to the same number. So what happened with the delivery fee? That changed it. The delivery fee made them not equivalent. So how do we use that information? How can we tell from a table if a relationship is proportional or non-proportional? I'm going to type this for you so that it looks a little prettier. So how can we tell in a table if a relationship is proportional? The ratios will be equal. We tested that by figuring out that they will simplify to the same ratio. If they are non-proportional, then they don't do that. If they're non-proportional, they will not simplify to the same ratio. Next, we are going to look at how we can find if a relationship is proportional or not from a graph. Our first question says to identify the rate of change using a graph. The rate of change is the exact same thing as the slope. So how do I identify the rate of change in a graph? We just have to find the slope. So we do what we have been working on, rise over run. And I know that my rise is 7 because it was 7 pizzas, and my run is 1. So my slope is rise over run for both graphs. Even with the delivery fee, the slope was 7. It had a rise of 1 and a run of 7. So how can we tell if a graph is proportional? We've already talked about this, but it's a very important skill. So we want to make sure that we really understand it. So how can we tell if a graph is proportional or non-proportional? It has 2 things. First, it has to be a straight line. Second, it has to go through the origin. It has to go through point 0, 0 in order to be a proportional relationship. I should label that a little bit better. To be proportional, a line needs to be a straight line, and the line needs to go through the point 0, 0. So I look at my graph, I can see that the first one is proportional because it follows both of those rules. It is a straight line, and it does go through point 0, 0. But my delivery relationship is not proportional. It is a straight line, but it does not go through point 0, 0. That's why it is not a proportional relationship from the graph. So from a graph, you can tell if it is proportional if it is a straight line and it goes through point 0, 0. It goes through the origin. And the last way that we are going to talk about how to find if a relationship is proportional or non-proportional is through the algebraic rule, through that equation. Remember that our algebraic rule for pizza with no delivery, the rule was y equals 7x. And then the algebraic rule for the pizza with delivery was y equals 7x plus 5. Because the 7 was how much the pizzas cost, and then that plus 5 was the delivery fee. Our first question says, how can you identify the rate of change using the algebraic rule? The rate of change is the exact same thing as the slope. The slope tells us how far something changes, how much something changes as it goes up and as it goes over. So how can we find the rate of change here? It's whatever is in the K or the M place. So whatever is in that place in front of the X, that's the rate of change. That's the slope. So for this question, our rate of change is 7. Because every time we bought one pizza, it changed $7. It went up $7 for every pizza. And part B, how can you tell if an algebraic rule is proportional or non-proportional? If it is proportional, It has to be in the format y equals kx. There can't be anything else. Or you might in the future see some situations where you will have to solve the equation to put it into the form of y equals kx. So it cannot have a plus or minus anything. If it has a plus or minus after the x, then it is non-proportional. So a non-proportional relationship would be in the form of y equals mx plus a b. So the thing that makes it non-proportional in most of these situations is that you will be adding a plus or a minus something on it. So it'll be plus or minus b. In this case, it was plus or minus 5 from the pizza delivery that changed it to a non-proportional relationship. So proportional relationships are y equals kx. Non-proportional relationships would be y equals mx plus b. And next, you are going to check to see if some relationships are proportional or not. So next, you are going to be using these 3 skills to practice.